Thank you very much. Thank you. I'm looking at my colleagues up there. Thank you. Good morning, everybody. So my name is Phil Lewis. I'm the lead architect for search and content analytics at Accenture. I'm based out of the London office, and I'm very, very pleased to be here in sunny Bratislava today. And I hope to talk to you a little bit today about using artificial intelligence in understanding the content of documents and how we use that to feed search engines and knowledge graphs to be able to answer specific questions that any organization, any user within an organization may have. So first, a little bit about me. As I've already said, lead architect for search and content analytics. I live in a place called Wokingham in the UK, which is very close to Reading, a great university town, of course. And if you're ever in the area, please pop in. My wife would like to offer you a nice cup of British tea. You can get me on that email address right there. But I've worked in the search industry for about 30 years or so, just a little bit more than 30 years now, so I really am an old guy. And in that time, we've done literally hundreds of projects with search engines and knowledge graphs and AI-based systems in recent years. And the organizations that I've worked with are pretty much across the board. As you can imagine, search engines are very horizontal, very much across the board. Everybody needs a search engine, at least to some degree. So lots and lots of organizations, lots and lots of project work. And we're constantly learning from one industry to translate that kind of feature into another industry. So in terms of what do we do with content once we understand it a little bit deeper, then most search engines, most knowledge graphs, most information systems will require some kind of index. We'll need to break it down, break that document down, and create an index. And it might be surprising, but indexes have been around a long, long time. This is an example from 1593, which is a document where a human has essentially decided what are the important terms within a document, what are not important terms within a document, and built a manual index on the back of the document. So instead of reading the whole thing, if you're interested in one particular subject, you can go to the index, you can then open the page, and you can read about that specific subject. So, of course, one of the greatest uses of indexation of documents today is an organization like Google. And we all love Google. They do about 2 trillion searches per year. Their index is, 100 million gigabytes in size. That's pretty scary size. 65,000 queries per second, 130 trillion pages on the internet tracked. Not all of them are indexed. Lots of them are classified as spam, and they are removed from the index. But over 130 trillion pages. And they have about 19 data centers doing this work for indexation of documents, extracting content from documents, and then providing searches over the top of that. And this is just a very simple photo that shows you the kind of power that you need in order to do this over 130 trillion pages of information. This is the data center heat output for your searches in Google. Okay? Any idea how many servers Google might have to do this kind of work? Any clues? We don't know because Google don't tell us. Can we do that? Thank you. We don't really know exactly how many servers Google have, but Gartner has recently estimated, in order to do what Google do, they have about 2.5 million servers. Okay? So again, a lot of servers to get this work done. And there's a very scary fact that's starting to happen. If you were in the keynote speech a little bit earlier by Mark, another Accenture colleague, he talked about the amount of information that the world has access to. And right now, towards the end of 2019, we're going to end up with about 44 zettabytes of data. But that is growing exponentially. Remember, he mentioned the word exponential in his speech. And we can see that by the end of 2025, only 5 years after the end of this year, we're going to be at about 175 zettabytes worth of information. Huge increases in this information. And what's even more interesting is that 80% of that data is unstructured. Okay? Only 20% is in a database, relational database. Only 20% is behind a schema. Okay? Everything else is just totally unstructured. It's documents, it's paper, it's video, it's audio. All of these things are traditionally not very easy to deeply understand. So that's where I come in. My role within the organization, and amongst many others, of course, is to try to understand this 80% of the world of information. We have a lot of colleagues working on the 20%. Our role as a series of technologists is to really try to understand the 80%. And the way that we've done that over the last 30 years or so is using search engines. But things are changing, and I'll show you exactly why in just a minute. So this is a typical user scenario with search engines. So we'll index the content, we'll understand that content, and at some point, I will have a question. I need to solve a question. Maybe I need some kind of fact. How many employees are in Accenture? Who is the CEO of Accenture? These may be questions I have. So I have a question, I need some facts, I build my query inside the search engine, I search, the search engine will then find me documentation, and it will make a hit list. It will filter that hit list and only give me the information that I'm supposed to see, secure-wise. And I'm talking now not about Google.com, of course, but search engines inside of companies, inside of organizations, because there's some documentation I'm not allowed to see, some documentation I am allowed to see. So the search engine has to know this before it gives you the result set. And then, of course, I read that list, and I read documents. I read some of the documents from the hit list. I don't read them all. And then, ultimately, I know the facts. Okay? So then I have a full circle effect. But things are absolutely changing. Our expectations are now more in the lines of asking questions to computers. So the paradigm is now not just finding documents, but it's finding facts. And these devices, the Siris, the Google Home Hubs, Alexas of this world, they're all giving us facts. So we're kind of changing our way of working from what we've done in the last 40 years by just typing in a few keywords into a search box into asking the questions to the system. And slightly changes the circle. So I need a fact, I ask a question, the system finds the facts, not me. The system finds the facts, it displays and reads the facts, and now I know the fact. Okay? So that middle section of me traversing a hit list is changing. So imagine if you asked a question of Siri or Alexa or any of these devices, personal assistant devices, something like, what is the population of Bratislava? And the Siri would come back to you and say, oh, I have found 2 million documents that may tell you that answer. Would you like me to start reading at document number 1? That's not the way the world is going, okay? We are very much changing this from searching and finding documents to searching and finding facts. It's called questions and answers. And you may have noticed facts are not documents, okay? So the little piece of information where it tells you the specific number of people that live in Bratislava, that's not a whole document, it's just a very distinct fact. And search is also changing because of this. And it's called today cognitive search. It embeds a whole bunch of AI-based technologies, a whole bunch of capabilities of deeply understanding content. And cognitive search is not the same thing as search was back in 2015 and before. So things are very definitely changing. So what is cognitive search? It's all about adding an artificial intelligence layer to a search engine. That includes natural language processing, it includes semantic understanding, machine learning, knowledge graphs, a whole bunch of other technologies in and around that to enable the search engine to be much smarter than it's ever been in the past. And Google is leading in what they're doing with cognitive search. And I'll just show you a couple of examples of cognitive search. You may be used to using Google, certainly prior to 2015, if you're old enough like me. You used to put in a few keywords. There was no concept of asking Google a question prior to 2015. And what happened actually in 2012 is that they added a knowledge graph to the Google.com service as well as a search engine. So they always had a search engine, they also added a knowledge graph, and I'll show you exactly how that works in just a minute. But it can now start to answer questions. And we can see at the top here, I don't know whether, is there a LED or a laser on this? No. Okay, doesn't matter. At the very top, you can see that there is a question: who is the CEO of Accenture? And the hit list of traditional documents actually starts all the way down here. Everything else you see, so this has come from a search engine, everything else you see has come from the knowledge graph. So Google is not just a search engine anymore. Okay? And a lot of the search engines which are held within organizations are now becoming these combined search engine and knowledge graph systems to formulate cognitive search. So we have a question, we have an answer. There's an answer card which has come up, which is the most prevalent answer that Google thinks that we should regurgitate this information for you. There's also an information card on the right-hand side, and it knows that Julie Sweet is part of Accenture. It knows that I've asked about Accenture in the query, and it gives us an information card on the right-hand side. We've seen this for many, many years. But you might not have known how it was done by Google. And this is where the result set really starts. And we can ask many, many different types of questions. So what is Accenture's revenue? It will give you an answer. How many employees does Accenture have? It will give you an answer. How many people live in Bratislava? How many people live in Slovakia, etc. All of these things you can ask questions of in Google. And they built this capability using a knowledge graph behind the scenes back in 2012. A really interesting question here. What year did Google add a knowledge graph? And Google gives you the answer, 2012. So it's kind of self-fulfilling. So today, right now, Google is probably still the most sophisticated cognitive search engine available. IBM's biting at their heels, and Microsoft Bing is biting at their heels. But I probably venture to say that Google is still the #1 out there. And everybody else playing in the search engine space is playing catch-up to what's happening with Google. Again, if you were in the keynote speech this morning, you would have seen a chart very similar to this. And I want to just iterate what Mark said in that communication to you a little bit earlier. And that is the fact that there are a lot of colliding technologies. And they're colliding in really, really interesting ways. And they are colliding in that space up there. Okay? And if you just go outside of that circle, maybe by just a few years, maybe back to 2010, if you look vertically down on 2010, these technologies weren't there. You know, we didn't have huge infrastructures available to us in terms of cloud-based computing. AI technologies back in 2010 were still play kits. They were toys, basically. But today, they're very highly professional tools that we can use. And all of these technologies are coming together, and that's why we can do this kind of thing now that we couldn't do only 8, 9 years ago. So just a couple of things about cognitive search and why it's different to traditional search. The first thing that cognitive search engines had to solve was really deeply understanding the words within the document. So this kind of document would have caused a problem for traditional search engines without AI. It uses the word developer, but if you read the words around that term, or that word, it does not mean programmer. Okay? It doesn't mean a programmer or a developer or a Java coder or anything like that. It means something else. This document does not talk about flowers, okay, which is a rose. And this document also does not talk about astronomy. Okay? So even though these words are in the document, they don't actually mean what most of us would think about these words if we didn't take the context of the document into consideration. So context is critical. And what Google did probably about 5 or 6 years ago was they invented a new technology to help us in this space. They called it RankBrain. It was based on some university research work that was in and around word embeddings. And the latest version of that, I guess, is BERT XL or various different names that these things go by. But what they're trying to do is to model human language inside of a computer using artificial intelligence systems. Now, what you're looking at is a chart, essentially, of the place that the word auntie takes inside of human language. just mapped out on this space. Now, this is a two-dimensional version of the real n-dimensional space. So imagine an n-dimensional space, more than 3 dimensions, okay? And a light shining through that model, and then the dots on this are just the shadows of where they are in the n-dimensional space. So this is not the model. The model is a much more complicated environment than just this. But if you think about, whenever I say the word, at least in English, auntie, you will have a mental model of what auntie means. And it probably, I'm hoping, it means family. It means maybe uncle, because aunties and uncles go together. And it just has that kind of feeling of where it should be in your mental space. Computers now know where it is, and they can put it in that space. And what's even more interesting is when you add other terms to this, like uncle, it puts it in the same mental space within the AI-based system, just like you do. And what's even more interesting is when it sees something like this. Auntie Beeb for us is the BBC. The BBC broadcaster. It's something we grow up with, we love. It always tells the truth, apparently. We love it, etc. But it's in a completely different mental space for me, as is within the AI-based system. And the AI-based system has completely learnt this just by reading documents and understanding these terms. Okay? And Uncle Sam, of course, is in a completely different space to Uncle. So now computers get less confused about those issues. And Google rolled out RankBrain in 2015, I think, and they immediately had an uplift of accuracy of 15%. No RankBrain, plus RankBrain, 15% improvement in accuracy of search engines immediately. Words do change, though, over time. So as we can see here, the word broadcast in 1850 did not mean TV, it did not mean internet, it did not mean live stream. There was no such technology. So broadcast as a word in the 1850s meant to sow seeds as a farmer. That's what it meant, okay? So if you're indexing documents from the 1850s, and many newspapers do, then the word broadcast is not about TV or radio. It's about farming. This is highly important, especially when you're trying to relevance rank documents. And AI systems can tell us this. Prior to the AI systems, we didn't really know this. We kind of knew it, but we didn't really know how to model it accurately within the systems. Google has built this word embeddings solution called BERT, which you can download. It's a free download from Google for many, many different languages. They have about 300 million words, at least from English, and it's only a 3.5 gigabyte download, so it's highly compressed. And these kinds of systems can now be built on your phone. So when you're speaking to the system, it really deeply understands the words that you're using within that environment. Okay, a little bit more about cognitive search, document understanding. And it's fairly clear what we do with documents if they contain text, but what if they don't contain text? How can we now use AI to maybe understand a little bit more about those documents that we couldn't understand before? Well, the first thing is, you've obviously heard of optical character recognition, or OCR technology. I worked on some of the very early optical character recognition systems in universities back in the day, when I was about this high. And the first OCR system was built in 1978, and they've been coming out from then. They've been able to obviously handle different fonts, different languages, even handwriting now, which we certainly couldn't do 30 or 40 years ago. But it's a kind of a technology that just takes data, takes images, turns it into text. We all understand it. It's been around a long time, but there are other things we can now start to do. So this is a piece of data that was sent to a Microsoft AI platform. And if you notice, there's no text on this image. It is really just an image. There is no file name given to the Microsoft API, so that they couldn't get any information from the file name. It was just the raw data of the image. And we asked Microsoft, with their AI-based image classification tools, to say, what do you think this is? What is it? And I just want to draw your attention to the top right-hand corner where it says text, which is almost at the end of the top box. text, and it thinks it's people waiting at a train station. That's pretty good. Okay? And there's a lot of metadata that Microsoft has regurgitated in and around that. So this is another way that we can extract knowledge from pictures using modern current technologies. This is an example of Google. You can see all of this stuff outside being demonstrated by the Accenture Labs guys. This happens to be a Google example, and it's just looking at a live stream, and it's classifying everything that it thinks it can see within that. Most notable omission for me, at least in this snippet, is that it doesn't understand what a guitar is. Okay? It doesn't understand that guitar. It sees the person, it sees the dog, it sees the couch, but in this particular example, it didn't understand what the guitar was. This is an example of Microsoft, again, trying to understand video. So the raw data is on the left-hand side, and the text has come live from the Microsoft Vision API. So every few milliseconds, every few hundred milliseconds, the Microsoft system is classifying what it thinks it can see in the video and tagging it all the way through. Classic, that is not a plant, but in the context that it saw, maybe this could be a plant. Okay, so it's not perfect. No AI system is absolutely perfect yet, but it is a very interesting technology. Okay, cognitive search number 3. So we've understood deeply the documents if we have text. We've understood documents a little bit better if they only have images. But even understanding the text, we need to go a little bit further. And we need to use other AI systems once we've got and extracted that text to deeply understand a little bit more about these pieces of content. So this is an example of doing natural language understanding and trying to work out what is this piece of text really saying. Okay? So in the top box, you can see there is a piece of text. It talks about this person, Gillian Russell, where she was born. She's the CEO of a company. She's the company secretary of another company. She lives in Wokingham with her husband, Phil Lewis. And once we process this text using AI-based technologies like natural language understanding, then we start to make relationships within this text. And it may not be obvious, certainly right away at the back, but you can see that the system is saying there is an entity called Gillian Russell. The system knows this is a human, by the way, just because of the context. Thank you. Somebody's pointing. Great. Aha. Thank you. Top button? Middle button. Okay. Got it. Great. Thank you. So Gillian Russell is an entity. There's another entity called Invercargill, which is a place, and it knows that this kind of relationship is a city of birth. It also knows that there's an entity called she, and then it goes down to a co-reference data structure, and it says, well, who is she? Because it says she is the CEO of Gingerbeard, but it doesn't say Gillian Russell was the CEO of Gingerbeard. So it follows back the mention back to a co-reference, and that co-reference is Gillian Russell. So it now knows that Gillian Russell is also the CEO of Gingerbeard Limited. So this is quite sophisticated, deep understanding of the content. Even though it's a relatively small set of data, there are a lot of links contained within this. A lot of good, strong information. Okay, so I think this is a little video of me doing this live. Come in. You're welcome. So this is a university tool, Stanford University Core NLP. All I've done is I've pasted the text into the box, and then I've asked it for co-reference information and relations, and very quickly it generates all of this data using machine learning and machine capabilities. Of course, then we can take this information and we can start to process it like facts. Remember, facts are not documents. So now we know some facts about this Gillian Russell person. Okay. And we might be able to visualize some of these facts using some other tools. So this is an example of a tool called Basis Technologies Rosette. You may or may not have heard of it. We use this a lot in a lot of our projects. And all I'm doing is I'm taking exactly the same text here, and I am pasting it into their tool. Their tool calls NLU capabilities, natural language understanding, natural language processing. I cut and paste the text in, and I say, please visualize this data. Okay. And it comes up, and it basically says, sorry, the resolution isn't particularly good here, but it basically says, I think Gillian Russell is the center of the universe for this paragraph, or for this text. And Gillian Russell is the spouse of Phil Lewis. Gillian Russell is a place of birth in Invercargill. Gillian Russell is a top employee of Gingerbeard Consulting Group. So we can see that we can just take a piece of text and turn it into facts very, very quickly using modern day technologies. But the facts are stored in documents. And we extract these facts, but we can't just put them back into the documents. We can't update everybody's document to say, oh, these are the facts. We need to store those facts somewhere else. And this is why we work with knowledge graphs, hand in hand, combined with the search engine today, so that we take these terms, these facts, and we push them to a search engine, but we also push them into a knowledge graph so that we can traverse and work with them. So we can see here, on the left-hand side, we have the original documents. We run them through an NLP layer, just as we've seen in the demonstrations. And we generate these graphs, okay? And you saw one example of generating a really simple graph for that one sentence, or a few sentences. And then this can become the powerful basis of a questions and answers system, which is not just a search system, it's much more than a search system. Okay, and I'll show you a few demos of these in just a second. And I'm hoping that you saw in the demo that it was extracting these facts. So it was extracting a semantic triple. We call this a semantic triple. We have 3 pieces of information which can model almost any fact. We have a subject, which is Gillian Russell. We have a top employee, which is Gingerbeard Limited. Gillian Russell, top employee of Gingerbeard Consulting. Gillian Russell, birthplace, Invercargill. When we have these facts, we store them in a knowledge graph, and then we can kind of traverse the knowledge graph to answer more and more comprehensive, complicated, useful questions and provide those answers to business people, just like Google does. So I'm going to give you a little demonstration now of this running fully end-to-end. And my first example is I'm using Elasticsearch as the search engine. I'm also using Elasticsearch as the knowledge graph in this particular demonstration. Okay, so any of you who've worked with Elasticsearch or played with Elasticsearch, it's a really good tool. It doesn't have to be the only tool. There's somebody here today talking about Neo4j, which is one of the most robust knowledge graph solutions that are out there. Really good, we work with that a lot. And if we were to productionize this kind of thing, I probably would prefer something like Neo4j or Mana or some other knowledge graph to work hand in hand with a search engine. But you know, as a search engine, it works both ways. So what we have here is I have taken a data feed from the UK government. And in the UK government, they provide every single company that's set up within the UK. So we can see we have about 4.3 million companies stored in this search engine right now. Very simple, just a very simple index of that data. But we can look at this data through a graphs perspective. So I'm going to open it up. And I'm just going to open the big picture view. And I'm going to do a quick search for something like Accenture. And we can see a whole bunch of relationships. Remember the relationships that we talked about a bit earlier? So we can see that there is a company called Accenture UK Limited. There's its company ID. It's an active company. It doesn't seem to have any more relationships than that at this moment. But there also is another company called Accenture Cloud Solutions, another company called Accenture Post Trad, whatever that is, Accenture PLC. These are all linked in some shape or form in there. There's also some other Accentures out here which are not active. They are in liquidation right now. Okay? So very quickly, we get this kind of description about what the world of Accenture is, at least from this initial data set. If I do the same thing, if I remove that and go in with something like Airbus, we can see the knowledge that we have on this particular company is very different. And this is just visualizing the facts that we know using a knowledge graph within that system. We can traverse these in really, really interesting ways. I'll give you one example to think about whilst I set up for the next piece. Oh, sorry, I haven't finished yet. Let me now open a director view. And remember, we had a company called Gingerbeard. And right now, the knowledge graph only knows about 4 companies. Out of the 4 million, knows about 4 companies that have this name Gingerbeard. And we can see their company IDs. We don't know whether they're connected in any way at this point, because the raw data we've got is quite limited from the UK government. But I'm going to feed some additional data in, which I've read from somewhere else, and we'll see if the knowledge graph can visualize that. So I'm going to go into our tool, and I'm going to feed company director information into that. So let me feed that in. And then I'm going to go back to this view. And all I'm going to do is say refresh. OK. So it really did index a whole bunch of content inside the knowledge graph, sorry, inside the Elasticsearch, and it started to make these connections. And the connections we can see are, now it knows about those same 4 companies, there's another one down there somewhere, but it also knows all of the directors that are involved. And we can see that Gillian Russell is kind of a top employee of this company, which is Gingerbeard Developments, but also a top employee of this company, which is Gingerbeard Limited. And we can now start to see these connections that we may not have seen before. I'm going to feed some more data in about the individuals. So right now, if I click on this and click plus, give me more information on Gillian Russell. You see it has no more data on this person. But I'm going to go here and add some more data about this person. OK, so I come here, and I click on plus, wait for it to finish indexing. Let me go here first. There we go. There we go. And one more, I'll just open this one. What more data have you got on this? So here, we added some information about the person's mobile phone numbers. We added some data about which cars they drive because of insurance information which has come in. So we've taken company data and we've merged it with UK insurance data, and we've merged it with BT billing, British Telecom billing records at the same time. So we can see, move this up a bit. Yeah. We can see that Gillian Russell has a phone number, 2 cars, and a postcode of where they live. So this is a really efficient way of visualizing the information we know about any individual fact. OK, so let me just restart up another very quick demo. I've got 6 minutes left. And the one I want to get rid of that, and I want to get rid of that. Just start this new demo up. Okay. So what we've done now is we've moved into a development environment that we work with a lot at Accenture. There's some tools here to ingest data from a wide variety of different data sets. So we use this tool to ingest the UK company data, the insurance data, the address data, et cetera, et cetera. That was the tool I was using to do that. We also have Kibana, which is the visualization tool. Various other tools in here, but this is the one I want to show you, which is our natural language processing tool, which is called Saga. And the first thing to notice is when we have processed these data types, we understand, because the NLU system is telling us what these things are, that there are a whole bunch of objects or entities called humans. There's a whole bunch of entities called companies. There's a whole bunch of entities called phone numbers, a whole bunch of entities called car registration plates, okay? And these entities are then tracked by this tool and many other tools working in reasonably similar ways. But I could come into this and I could say, what have you got on Gillian Russell? Okay, and we can see we've got an entity. That's the entity ID. You can see it's a little bogus, but you can see an entity ID there, Gillian Russell, and we can see all of the different variations of a name that we've detected for Gillian Russell within these elements of content. I can come back, I can say, what have you got on Gingerbeard? And we can see that we've got multiple entities on Gingerbeard and what they're called. And of course, we've got entities galore. So Elon Musk is in there. Tesla is in there. Accenture is in there. So this is kind of an entity list. And this has all come to us from this natural language understanding, natural language processing solution. So what we can do is then we can build a questions and answer system on top of this knowledge graph, this search engine, content processing, and knowledge graph solution, so that we can start to answer questions that search engines really can't answer. So I'm going to give you a live demonstration of that now. I'm just waiting for my demo to fully load. Let me see where we are. Saga server and Saga parser. Ah, we're up. Great. Okay, so let's ask it some questions. Who is the boss of Gingerbeard Limited? Okay. What industry is Gingerbeard in? When was Gingerbeard founded? But it's not just about Gingerbeard. It's about all of these companies, all of these people, all of these cars that we've ingested into the system. So, when was Tesla founded? Who is the boss of Tesla? Where was Elon Musk born? Last couple of examples. What is the population of Japan? And for my Costa Rican friends, chart the population of Costa Rica. Okay, so all of this data has come from the knowledge graph that we have pre-populated by the same tools that's populating a search engine. They're working in a slightly different way. They're looking at much more finer granularity of the content itself than a search engine does, because a search engine just essentially indexes everything. But these two technologies working hand in hand can give us very, very powerful capabilities. This is like an early prototype, if you like. But all we're trying to do is to do the same thing that Google does, but over your data, not Google's, not the internet, but your company's data. What is the population of Japan? Okay, so hopefully that's given you a good understanding of where AI can help, why AI is starting to really make a huge resurgence into this space. It's now no longer just a university tool, play toy. It's really going out there into industry and having a huge impact on how we interact with data. And we need to do this because when we get into the 175 zettabytes of information that's available to us, we simply won't have time to read all of the documents that a search engine will tell us. We need to get straight to the facts. And the only way we can do that is through cognitive search capabilities, deeply understanding the content of documents and then providing these additional services on top. Okay? So I'm going to stop there and just open it up to any questions. Any questions?
Okay. So thank you very much for this very nice presentation. I have one question, which is, today we are assuming that everything we see on Google is actually fact.
Yeah.
Okay?
Yeah.
So now my question is, in the world of deep fakes,
yep.
okay, or deep fake videos, or fake news, or fake voices, how actually we can prevent ourselves from being, impacted by these fakes? How
Absolutely.
Google actually can prevent us?
Yes. This is a really, really good question.
Thank you.
And what's more important is the fact that it may not be obvious how many people... I don't know if you know, but when Google first started, almost nothing was automated within the system. There was a lot of human involvement in hand curating whitelists, hand curating the right pages from the documents to be put into the system. And over time, they absolutely automated that whole process. So it now just looks after itself. The questions and answer system with Google, there is a lot of human effort that goes into this as well. So the system will kind of think of or read what it thinks is a fact. And then there's a whole bunch of really clever algorithms and people that come in and say, no, this is a real fact, this is not a real fact, this is bad, this is good. And it's kind of like that Saga user interface thing that I showed you a little bit, but well beyond that. The other key thing to mention, and that's a really good question, is fact arbitration, right? So one person may say white is black, another person may say white is white, another person may say, black is white. So how do you work out what is real? Google can kind of do this quite well because they have the internet, and the internet is a very authoritative source, hierarchical authoritative source of information. And they know who's the #1 source of information from any given domain. So if you're talking about BMW cars, then BMW is the #1 authoritative source. And I doubt BMW will put bogus information on their website. So when they get facts from BMW website about BMWs, they know they are the most authoritative facts. If they get a fact from my website about BMW that's non-authoritative, it is not a fact. Okay? And this is how they arbitrate. And they can kind of do this. They still need a number of people in their human community to sift through this. When we try and do this inside of companies, okay, you could argue it's a little bit easier because the information that is stored in companies also has a hierarchy. There is a whole bunch of content sources which are the most authoritative content sources for a company, like SAP, like ERP systems, like a whole bunch of these systems, which are generally regarded as this is the lifeblood of the company, and this information is accurate. If we go down a step down to my emails, then reading facts from my emails is not necessarily authoritative. Or reading facts from a document on a disk, on a file system in the middle, just a dummy document somewhere, that's not necessarily authoritative. So we need to build this hierarchy of the information that we trust, and then we can have a good, better understanding of where the facts really are. So it's a really good question. And something we're still trying to solve today. So it's not a piece of software that we install and say, go, find out all the facts in this company. We install the tools, we put a whole bunch of business rules into the system and say, these are your most authoritative data sources. These things do not trust. You may read stuff there, but don't trust it. And we build all of that for our customers. Good question.
Okay. Actually, we have really a little space of time, so okay. I would like to thank to Mr. Philip Lewis, but we don't have any space for other questions, so thank you, and so the next presentation will be held.